In today's lesson, you will learn how to solve equations involving one step. You'll have been successful if you can do this by the end of the lesson. Okay, so let's start with what is an equation. An equation is a mathematical statement that two expressions are the same. For example, a equals pi r squared. The equals tells us that the expression on the left-hand side of the equation is equal to the expression on the right-hand side, so this is an equation. An equation must always have an equal sign in it. And another example is a squared plus b squared equals c squared. An example of an equation more similar to what we are going to be looking at today is x minus 2 equals 4. We are going to look at how we would solve this equation. This equation states that the expression on the left-hand side of the equals is the same as the expression on the right-hand side. So, in order to solve this equation, we ask ourselves, what must the value of x be so that this equation is true? So what number take away 2 does equal 4? Well, we could probably just do this by looking at it. The number that take away 2 gives 4 is 6, so x equals 6, and that is the equation solved. In order to solve an equation, our goal is to have x on the left-hand side of the equation on its own. When you have done that, you have solved the equation. So looking at a similar one to our last example, I'm going to show you the method that we would use to solve these. Now this might seem a bit unnecessary at this stage, but as we look at more difficult ones, it will definitely help us solve them. X take away 2 equals 6, so we would like x on its own. The issue is that minus 2 is on the same side of the equals as the x. So we need to cancel out the minus 2. In order to do this, we do the opposite of taking away 2, which is adding 2. However, if you do something to one side of an equation, you also need to do it on the other side. So we need to add 2 to the other side. Remember, when I talk about the two separate sides of an equation, I mean on either side of the equals. So minus 2 plus 2 gives me 0, so all I'm left with is x equals, and on this side I've got to do 6 plus 2, which gives me 8. Does that make sense? Yes, because 8 take away 2 is 6. In example B, solving the equation, we would like y on the left-hand side by itself. The issue is there is a take away 4 on the same side as the y. So in order to cancel this out, we are going to add 4. That's the opposite of taking away 4. However, if I do this to the left-hand side, I also need to do this to the right-hand side. Minus 4 plus 4 gives me 0, so I'm just left with y equals, and 5 plus 4 gives me 9. Y equals 9 is our final answer. Okay, example 2. To solve the equation, I would just like a equals. Currently, I've got a plus 3 on the same side, so I want to get rid of that plus 3. The opposite of adding 3 is taking away 3. If we do that to one side, we must also do it to the other. Plus 3 take away 3 gives me 0, so I'm just left with a equals. 2 take away 3 gives me negative 1. A equals negative 1 is our final answer. And for B, B plus 5 equals 7. I would like to get rid of the plus 5 as it is on the same side of the equals as the B. The opposite of adding 5 is taking away 5, so I'm going to take 5 away from each side. Plus 5 take away 5 leaves us with just B, and 7 take away 5 gives 2. Okay, so example 3 is slightly different. Now remember, if we have a number and a letter sat next to each other like so, this actually means 3 is multiplying p. So in order to solve this equation, we would like p by itself. The issue is there is a 3 multiplying p. How do we approach this? So, in order to get rid of that 3, we're going to do the opposite of multiplying by 3, which would be dividing by 3. However, if we do that to one side of the equation, we need to do it to the other side of the equation. 3p divided by 3 just leaves me with p equals 12 divided by 3 is 4. In part B, 5 is multiplying the t here. In order to get t by itself, we'll divide by 5, but we'll do this to each side. 5 divided by 5 gives me 1, so I'm just left with a t on the left-hand side. 25 divided by 5 gives me 5, so t equals 5 is my final answer. Again, slightly different in example 4. I've got a third x equals 4. So, what does a third x mean? Well, remember, if you're finding a fraction of a number, you're dividing by the bottom, timesing by the top. This means that we're dividing by 3 timesing by 1. So effectively what this means is x is being divided by 3. So in order to approach this one, we're going to multiply each side by 3. That is the opposite of dividing by 3. That will leave me with x equals 4 times 3 is 12. For part B, here I have r being divided by 5. If we're taking a fifth of it, we're dividing by 5. So in order to solve this one, I would need to times each side by 5. That will leave me with r equals negative 3 times 5 is negative 15. And lastly, example 5. This is very similar to the last one. This is a divided by 2 here. So in order to solve this, we must multiply each side by 2, since that is the opposite of dividing by 2. That leaves me with a equals 10 times 2 is 20. M is being divided by 3 here. In order to solve this, we must multiply each side by 3. That is the opposite of dividing by 3. That leaves me with m equals 9 times 3 is 27.